Okay, so here we're going to be talking about these curvature problems in R2. So these are these 6 exercises here, but we're going to do these one at a time. We're going to start doing just PC4. Okay, so when you have a, oh, I forgot to get my pen out. When you have a curve, let's see here, wait a second. Right, so when you have a, oh gosh, I'm still getting organized here. Okay. Yeah, so you've got a parametric curve in the XY plane. And we have a picture of this on the other page over there. Maybe I'll roll over to it in a second here. But so at any point, we have a velocity vector. And here's the parallel to the x-axis, and that defines this angle here, phi. Right. And we know that dy dx is equal to tan phi. Okay. So what we want to do here is define phi prime. Right? In other words, we want to take the derivative with respect to time of phi. And, well, now one thing you could do is you could solve for phi, and you could have arctan, and you can use known facts about the derivative of arctan, and that's perfectly fine. I'm going to do it here in a slightly different way. Oh, and by the way, note the hint tells us that this dy dx can be thought of as y prime over x prime. In other words, that's dy dt divided by dx dt, and I hope that seems believable. Is that okay? Yeah. All right. So I'm just going to do an implicit differentiation, effectively, of this. So I haven't solved for phi, but I'm going to take a derivative of the whole thing, and the derivative that I want is going to fall out. So let's take the derivative of the left side with respect to t, and well, the derivative of tangent is secant squared, but we got to use the chain rule. I also have to multiply by phi prime. Is that okay? All right. Now on the right-hand side, okay, so here we have the quotient rule. This is my downfall. I never can remember which way the quotient rule goes, and I think it's, so we're going to have a product minus another product, all divided by the denominator squared. Yeah, that's right. Let's get the glare off of there. And I believe that the first prime goes there and the second prime goes there. Is that right? I easily could have gotten that backwards. Yeah, I for some reason I have a little mental block about that. I never can remember it. Okay, let's go with that. I think it's probably right. Okay, so here's the good news. This secant squared I could rewrite as 1 plus tan squared. And all that stuff is still the same. And well, but tan phi, we know tan phi is y prime over x prime. So this is 1 plus y prime over x prime squared phi prime equals all that stuff. So now I solve for phi prime. And the way I solve for phi prime is, of course, I just take all this stuff here and just bring it down into the denominator of the other side. So on the other side, I get y double prime x prime minus y prime x double prime all over, let's see here. Well, we're going to have this business times x prime squared, and that gives me x prime squared plus, well, let's see, x prime squared times that is that x prime squared is going to cancel with that x prime squared and get y prime squared. We get that there. Is that all right? Yeah. And let's see. By the way, is this what we needed to show, or I've forgotten what? Let's see here. We're on number 4 right now. Yeah. So find a formula for phi prime. There we go. In terms of the derivatives of x and y. And that's what we have here, phi prime in terms of the derivatives of x and y. All right? Cool. All right, let me stop this.